Hello friends, welcome to Learners Planet. Friends, in this session we are going to see how to calculate unit digit of a mathematical expression and cyclicity of power. These sort of questions are asked in various competitive exams like CAT, Z, bank probationary officers, other MB entrance examinations, maybe Olympiad examinations. So let's begin today's session. Now let's take the first example over here. What is the unit digit in the product of 274 into 318 into 577 into 313? Friends, it is very easy to solve. You don't even need a paper and pen. What you can do is you start multiplying the unit digit and drop the and if you get a tens digit in the multiplication, you can drop that. So I start from this unit digit. So 4 into 8, 32. I get 32. I'll drop 3 and I'll continue with the unit digit, that is 2. So that 2 into this 7, I'll get 14. I'll further drop 1. I'll be continuing with 4. That 4 into this 3, 12. So finally I'll be getting 12, but the unit digit is 2. So the correct answer is 2. It's very simple, friends. We just have to keep on multiplying the digits at the unit place, and then we have to drop the tens digit if we get two digits in this multiplication. So I hope you are clear about the method. Let's do more problems. Now let's take this problem. What is the unit digit in the what is the digit in the units place of product 81 into 82 till 89? The problem looks like tedious, but actually it is very simple. Let's begin to calculate. Friends, here we are having an even number, and definitely in this sequence number 85 will be there. That will be a multiple of 5. So whenever we are multiplying an even number, and 5 will be getting 0 at the end. So no need to calculate further. Definitely we are going to have 0 at the units place. So 0 is the correct answer. Let's take another problem. Now in this case, if the unit digit in the product 459 into 46 into 28 star into 484 is 2, then we have to find out the value of this star. Let's begin to the problem. 9 into 6, 54. I'll drop 5 and I'll continue with 4. I'll skip this number, and that 4 into this 4, I'll get 16. So that means I'll be getting 6 at the unit place, but I want 2. So the minimum number, either the number in the option should be such like if I multiply that by 6, I'll be getting 2 at the units place. So 6 into 3, 1 produce 2. 6 into 5, 1 produce 2, but 6 into 7 will produce 42, and I'll be getting 2 at the units place. So 7 is the correct choice in these options. Other option can be 2 also, because 6 into 2 is also 12, but 2 is not there in the options, so we'll choose 7. I hope you are clear about the problem. Now friends, we see the cyclicity of power. In various competitive exams, we are asked to calculate the unit digit of very big numbers, maybe 2 raised to 100, maybe 5 raised to 99, maybe 35 raised to 400, maybe 47 raised to 325. These sort of questions are there, and we have to calculate the unit digit. In these sort of cases, we have to, if we wish to calculate the unit digit, we need to understand cyclicity of power. So let's begin. The unit digit of n raised to x will be an even number if n is an even number, and unit digit will be odd if n is an odd number, and here x is any positive integer. Suppose I wish to calculate 4 raised to anything, then the unit digit will definitely be an even number, since 4 is an even number. And similarly, if I wish to calculate 3 raised to anything, then in that case the unit digit will be an odd number, whatever it may be, but it will be an odd number. Similarly, fourth power of any even number will always have unit digit as 6, and fourth power of any odd number will have the unit digit as 1. Only 5 is the exception. In any case, if you raise 5 to any power, it will always produce 5 at the units place. Let's elaborate this. Now friends, let us learn to calculate the unit digit of any number. We have here 9 options with us for the unit digit. Unit digit may be 2, 3, 4, 5, 6, 7, 8 or 9. If it is 0, then there is obviously zeros at the unit place, whatever power is given to it. Okay, so let's learn to calculate the unit digit in these cases. Now friends, let's begin the calculation with 2. Now 2 raised to 1 will be 2, 2 raised to 2 will be 4, 2 raised to 3 will be 8, and 2 raised to 4 will end in 6, and further 2 raised to 5 will end in 2. Let's discuss this method in some expanded manner. I just show you my hand over here, and we'll learn to calculate this entire thing on our fingers itself. So even in examinations, it will save lots of time. We don't have to go for the paperwork. So let's see how does it happen. Now friends, I'm just showing you a hand over here, and we are going to calculate these numbers on our fingertips, these unit digit on our fingertips. Let's begin with 2. So suppose I wish to calculate 2 raised to 5. Then it will be, let's begin with our first finger. It's 2 raised to 1, that will end in 2. Then 2 raised to 2, that will be 4. Then further 2, 4 2s are 8, 8 2s are 16. I got 6, I'll drop 1. Then 6 2s are 12. So I started with 2 from here, and further I got 2 over here. So if any number raised to 5th power, it will end in the same number, same digit. Okay, so let's fill up the table. I see here 2 raised to 1 is 2, then 2 raised to 2 4, 4 2s are 8, 8 2s are 16. I drop 1 and I write 6, and 6 2s are further 12. I write 2 and I'll drop 1. Similarly, we calculate it for 3. Let's begin. 3 raised to 1 3, then 3 square, that is 9. 9 3s are 9 3s is 27. I got 7. 7 3s are 21. I got 1 at units place, and 1 3s are 1 3s is further 3. So whatever I started with 3 and I end up with 3. That means 3 raised to 5 will also end in 3. Let's fill up the table. It's 3 raised to 1 will end in 3. 3 3s are 9. 9 3s are 27. I'll write 7. I'll drop 2. 7 3s are 21. I'll write 1. I'll drop 2. Then 1 3s are 3. Now let's calculate it for 4. 4 raised to 1 will end in 4. 4 4s are 16. That will end in 6. Then 6 4s are 24. Further we are getting 4. Then 4 4s are 16. Further we are getting 6. Then 6 4s are 24. Further we are getting 4. So the sequence will go like this: 4 6 4 6 4. That means if 4 is raised to any odd power, it will produce 4. If 4 is raised to any even power, it will produce 6. So let's fill. It's 4 raised to 1 will end in 4. 4 square will end in 6. Then 6 4s are 24. 4 4s are 16. So we'll be getting 4 6 4 6 and so on. So I would repeat over here. If 4 is raised to odd power, will be getting 4, and if 4 is raised to even power, then we'll be getting 6. Now, as we have already discussed, in the case of 5, every time the unit digit will be 5 to whatever power it is raised. So it's 5 5, 5, 5 and 5. Now we take the case of 6. It will also produce 6, whatever power it may be raised. 6, 6, 6, 6 and 6. Now we take the case of 7. Let's move to our hand. So it's 7 raised to 1, that is 7. 7 sevens are 49. I'll be getting 9. Then 9 sevens are 63. I'll be getting 3. Then 3 sevens are 21. I'll be getting 1. And 1 sevens are 7. 1 7 is 7. So further I'm getting 7. I started with 7 and I'm getting 7 at the end. So let's fill up the table. It's 7 raised to 1 will end in 7. 7 sevens are 49. 9 sevens are 63. 3 sevens are 21. And 1 7 is 7. Similarly, we can take the case of 8. 8 raised to 1. 8. 8 eights are 60. 4. 4 eights are 32. 2 eights are 16. And 6 eights are 48. So further I got 8. Similarly, the case of 9. 9 ones are 9. 9 nines are 81. 1 nines is 9. Then 9 nines are 81. So in case of 9, we'll be getting 9 1 9 1 9. So if 9 is raised to odd power, then it will produce 9. If 9 is raised to even power, it will produce 1. So we can make this table just by calculating the numbers at our fingertips. It is very simple, friends. You can do it mentally whenever you are required. You just don't memorize the table. You just calculate immediately whenever it is required. Okay. Now let's discuss some problems based on this. Friends, before starting the problems, let's make some observation over here. Here we see if we raise 2 to any power, we'll be getting 2, 4, 8, 6, 2 and the sequence will go on. That means 2 is maintaining a cycle of 4. Here we see 2, 4, 8 and 6. Further we'll be getting 2, 4, 8 and 6. Right? So 2 is maintaining the cycle of 4 as far as the case of power is concerned. Similarly, in the case of 3, we are getting 3, then 9, 7, 1, further 3, 9, 7 and 1. That means 3 is also maintaining the cycle of 4. Similarly, in the case of 7 and 8. Okay, so 2, 3, 7 and 8 are maintaining the cycle of 4. And if we see the case of 4, 4 raised to 1 is 4, 4 raised to 2, that will end in 6. So we'll be getting the series of 4, 6, 4, 6, 4, 6 and so on. So that means if 4 is raised to any odd power, we'll be getting 4 at the units place, and if 4 is raised to any even power, we'll be getting 6 at the units place. Similarly, in the case of 9, if 9 is raised to any odd power, we'll be getting 9 at the units place, and if 9 is raised to any even power, we'll be getting 1 at the units place. We don't have to memorize this table. We have already learned how to calculate this on our fingers. So even in exams, you should do that only. You don't have to use any paper and pen. Okay, now let's do our first problem. Now let's take this problem. Here we have to find out the unit digit of 3127 raised to 173. That means we have to calculate the unit digit of 7 raised to 173. Now we have already discussed that 7 maintains the cycle of 4. That means we have to divide 173 by 4 and we have to get the remainder. As far as the divisibility test of 4 is concerned, we have already discussed in our divisibility test session that the last 2 digits should be divisible by 4. So if I divide 73 by 4, what I'll be getting? 1 as a remainder. That is 72 is the last number which is divisible by 4 below 73. Right? So 7 raised to 173 and 7 raised to 1. The unit digit of in both the cases will remain same. So what the unit digit of 7 raised to 1 will be? It will be 7 only. Okay, friends. So the final answer to this problem is 7. Similarly, I can take up any other number, maybe say 3 raised to 47. Now 3 also maintains the cyclicity of 4. So the last number that will be divisible by 4 below 47 will be 44. So if we divide 47 by 4, we'll be getting 3 as a remainder. So we have to calculate the unit digit of 3 raised to 3. So let's begin. That is 3 into 3 into 3. 3 threes are 9 and 9 threes are 27. So what we'll be getting at the units place is 7. Okay, it looks like a very big question, but the problem actually it is very simple. You just have you can do it mentally, even if you use your fingers properly, if you have understood the concept properly. Fine, friends. Now let's try this problem. In this case, we have to calculate the unit digit of 7 raised to 71 and 6 raised to 559 and 3 raised to 65 as well. So let's begin with 7 raised to 71. Now 7 maintains the cyclicity of 4. So the last number below 71 which will be divisible by 4 is 68. So we will get the remainder as 3. And what 7 raised to 3 is? It's let's begin to calculate the unit digit of 7 raised to 3. That is 7 into 7 into 7. So it's 7 sevens are 49, 9 sevens are 63. So unit digit in this case will be 3. And 6 raised to 59, it will end in 6 only. So it's 6. Then 3 raised to 65. The last number below 65 which will be divisible by 4 is 64. So we'll be getting the unit digit as 3 raised to 1 which will be 3. So it's 3. Now 3 6 are 18. We'll drop 1. We'll continue with 8. That 8 into this 3, that is 24. So what we'll be getting at unit place is 4. Isn't it very simple, friends? Now the digit in the units place of the number represented by 7 raised to 95 minus 3 raised to 58. Okay, now let's begin to do this problem. We have been given 7 raised to 95. Let's calculate the unit digit of 7 raised to 95. What is the last number that will be divisible by 4 below 95? That will be 92. So if 95 is divided by 4, we'll be getting 3 as the remainder. So the unit digit of 7 raised to 95 and 7 raised to 3 will be same. So let's calculate the unit digit of 7 raised to 3. Let's begin from our fingers. So it's 7. 7s are 49. 7s are 63. So the unit digit will be 3 in this case. Similarly for 3 raised to 58, the last number which is divisible by 4 below 58 is 56. So the unit digit we have to calculate, it will be same as 3 raised to 2. That will be 9. Okay, now what 3 minus 9 is? It's actually minus 6, and we cannot write minus 6 at the units place. So from the entire calculation we have to borrow 1. So what will be the unit digit? That is 10 minus 6, that will be 4. Isn't it so simple, friend? Now in this question, if x is an even number, then x raised to 4n, where n is a positive integer, will always have. Now we have already discussed, if x is an even number, the fourth power will always end in 6, as far as the case of 2, 4, 6 and 8 is concerned. But we have 0 also at the units place in many even numbers. So if 0 is raised to any power, it will produce 0 only. So the answer to the problem will be, it's either 0 or 6 in the units place. Okay, friends? Now let's see this case. Here we have to calculate the unit digit. So it's 4 into 8, 32. Drop 3 and continue with 2. That 2 into this 7, 14. Drop 1 and continue with 4. 4 into 3, 12. So what we'll be getting as unit digit is 2. This case is very simple. In the entire sequence, one number 185 will be there definitely, and there are even numbers also. So if we multiply 5 to any even number, a 0 will be produced. Okay friends, so at the units place we'll be getting a 0 only. Now let's take some random problems. Suppose I wish to calculate the unit digit of 4 raised to 448. Okay. The case of 4 we have already discussed. If 4 raised to any even power, it will produce 6. So the sequence of 4 will be 4 raised to 1 will end in 4 and 4 raised to 2 will end in 6. So the sequence is 4 6 4 6 4 6. So 4 raised to uh, if 4 is raised to any even power will be getting 6. So 4 raised to 448 will be ending in 6. Similarly, we can take the case of 9. It's if 9 raised to 37. So if what 9 raised to 1 is, it will end in 9. 9 raised to 2 will end in uh, it's 81, so it will end in 1. So we'll be getting the sequence of 9 1 9 1 9 1. So if 9 is raised to odd power, it will produce 9, and if 9 is raised to even power, it will produce 1. So in this case, we'll be getting the unit digit as 9 only. Now suppose I take a bigger calculation. Suppose I wish to calculate 2 raised to 52 into 3 raised to 53 into 4 raised to 54 into 5 raised to 56. What will be the digit at the units place in this calculation? So as soon as you see the problem, you start calculating. Here you just have to make one observation. We have even numbers over here and we have 1 5 over here. We have even 56 fives over here, but we need only 1 5 and 1 2 to make a 0. So in this case, a 0 will be produced at the unit place. So the answer is 0. Okay friends. Now let's take one more problem. Is 3 raised to 53 into 5 raised to 57 into 9 raised to 68 into maybe 11 raised to 75. Now this problem looks like a very tedious, very big, but you just have to make one observation over here, that any odd number, if it is multiplied by 5, it will always produce a 5 at units place. Doesn't matter how big the number is. Okay, so in this case, there is no even number. All the numbers will be odd numbers. If we calculate 3 raised to 53, it will produce an odd number. If we calculate 9 raised to 68, it will produce odd number. And if we calculate 11 raised to 75, even it will produce an odd number. So if any odd number is multiplied by 5, it will produce 5 at units place. So further, no need to calculate. Now friends, let's try this problem. We have to find the unit digit in this case, that is 7 raised to 83 plus 5 raised to 84 plus 6 raised to 85 plus 8 raised to 88. Friends, in this case, that is 5 raised to 84, will be getting the unit digit as 5 only. And in this case, 6 raised to 85 will be getting the unit digit as 6 only. So we have to calculate the unit digit of 7 raised to 83 and 8 raised to 88 only. Now let's begin with the 7 raised to 83. 7 maintains the cyclicity of 4, so we'll divide 83 by 4, we'll be getting 3 is the remainder. So the unit digit of 7 is to 3 will be 7, 7s are 49, 9 7s are 63. So it will be 3. And in this case, 88 itself is multiple of 4. So the unit digit of 8 raised to 88 will be same as the unit digit of 8 raised to 4. And any even number except 0, if it ends in if it raised to any power that is multiple of 4, you will be getting 6 at the units place. So 8 raised to 88 will end in 6. Now we can calculate the unit digit, that is 3 plus 5 8, 8 plus 6 14, drop 1 and continue with 4, that 4 plus 6, that will be 10. So what we'll be getting at the unit place is 0. It's very simple friends. Now let's take one more problem. Suppose I have a number 9 raised to 87 into 3 raised to 85 into maybe 7 raised to maybe 104 into 6 raised to 32, and I have to calculate the unit digit of this expression. Now as far as the case of 6 is concerned, the unit digit will be 6 only, and if 9 is raised to any odd power, it will produce 9 at the units place, so it will be 9. Now we have to calculate the unit digit of 3 raised to 85, and 3 maintains the cyclicity of 4. So 85, it is divided by 4, will be getting the remainder as 1. So the unit digit of 3 raised to 85 will be same as the unit digit of 3 raised to 1, that is 3. So I write 3 over here. Then 7 raised to 104. 104 itself is a multiple of 4. So the unit digit of 7 raised to 104 will be same as the unit digit of 7 raised to 4. So if the unit digit of 7 raised to 4 will be 1, since we have already discussed, if any odd number except 5, if it is raised to any power of 4 or multiple of 4, it will produce 1 at the units place. So 7 raised to 104 will have 1 at the units place. Now let's begin to calculate the final unit digit. So it's 9 3s are 27. We drop 2, we continue with 7. That 7 into this 1 will further give 7, and that 7 into this 6 will produce 42. So what we'll be getting at the unit place is number 2. It's very simple, friends. Now friends, let's try this problem. We have to calculate the unit digit of this big expression. So let's begin with 133 raised to 725. So the unit digit of this expression will be same as the unit digit of 3 raised to 725. Now 3 maintains the cyclicity of 4. Okay, so the unit digit of 3 raised to 725 will be same as the unit digit of 3 raised to 1. Okay, if we divide 25 by 4, we'll be getting 1 as remainder. So it will be 3 only. Similarly, we take the case of 62 raised to 33. So we have to calculate the unit digit of 2 raised to 33. So if 33 is divided by 4, we'll be getting 1 as a remainder. So the unit digit will be same as 2 raised to 1, which will be 2. Similarly, the case of 27 is concerned. 7 also maintains the cyclicity of 4, and if 482 is divided by 4, will be getting 2 as remainder, since 80 is the last multiple of 4 below 82. Okay, so the unit digit of 7 raised to 2 will be 7 7s are 49. So what will be getting at units place is 9. Similarly, 52 is multiple of 4. So the unit digit of 8 raised to 52 will be same as the unit digit of 8 raised to 4, and which will be 6. So let's calculate this. 3 minus 2 1, 1 plus 9 10, 10 minus 6 4. So the unit digit of this big calculation will be 4. I hope you are clear about the cyclicity of power and how do we calculate the unit digit of this big expressions. We'll be taking more examples when we are going to discuss some more multiple choice questions in our next sessions. I hope you are clear with all the concepts. You should practice with the concepts and make it a habit to do calculations mentally. All the best, friends. Let's meet in the next session once again. Bye bye.